Hello friends, this is Rajiv Ranjan, a student of MTech from Bennett University. Here I am going to present a video on K-means. We have learned about machine learning that there are two types of machine learning, that is supervised learning and unsupervised learning. Supervised learning is based on classification method and unsupervised learning is based on clustering method. There are lots of clustering methods like hierarchical clustering, partition clustering, exclusive clustering and overlapping clustering. The very important is K-means clustering, right? So let's see what is K-means clustering. So let's know about K-means clustering. So it explores data analysis technique, that is it analyzes the complete set of data first before doing the clustering methods, whatever the procedure is. Next, it implements non-hierarchical method of grouping objects together, that is it will not follow any certain frame format of object. It just takes the input and with the procedure of K-means clustering, it separates the objects in their respective clustering. Next, it determines the centroid using the Euclidean method for distance calculations. So here it just has to calculate the centroid value, and for that it used the Euclidean method for calculating distance between them. And last, it groups the objects based on the minimum distance. So whatever the minimum distance, the object will be the part of that clustering which is just a minimum distance from that, right? So we can see here in this image, right? So this is the image of different colors. So after applying K-means clustering, what it does, it simply separate all the images in their partitions, like all the red colors in this image get grouped together here, and all blue colors in this image get grouped together here, and all green colors grouped together here. So this is the basic applications of K-means clustering, right? So see here the flow chart of K-means clustering. So first start and then input the number of clusters, right? So we have to decide how many number of clusters will be there to separate the objects, right? Thereafter it will calculate the centroid value, right? And then it will just calculate the distance, right? And at last group based on minimum distance. So after calculating the distance, what will be the minimum distance, based on that minimum distance, it will group the objects in their respective clusterings. And this procedure will continuously follow until it will not get consistency in clusterings, means all the objects or data set until not get their certain space in their respective clustering, right? So let's see how generally what is the methodology of applying K-means clustering. Suppose for applying a K-means clustering for following data set for two clusters. So I have tabulated all the assignments here. So this is the data set. In here I have taken 6 samples, right? This is very less samples for just to understand. So there will be the less complexity to understand. So I have just taken 6 samples and their respective data, right? So let's see how we will compute it, right? So first we have to decide the number of clusters, that is in how many clusters do you want to separate your objects, right? So I just want to separate these data set in just 2 clusters. So I have taken here k equals to 2, k is clusters, right? So I have 2 clusters, k1 clusters and k2 clusters, and for the initial centroid we have to just decide initial centroid initially. So I have taken initial centroid as initial centroids these two data set 185 and 72 here, and 170 and 56 here, right? So this is not necessary to take first two data set as initial data. You can just select randomly any data among these one, right? So just for the better understanding, I have selected the first two data set here for the initial set, right? Okay, so come on, let's do the computation. So as per the principle and the flow chart we have seen for the k-means clustering, we use Euclidean distance for computing the distance between centroids. So we know that the equation for calculating distance with the help of Euclidean distance is this one, that is x comma y comma a comma b equals to root under x minus a to the whole square plus x minus b to the whole square. So xy is the coordinates of first cluster and ab is the coordinates of second clusters, right? So according to the following equations, we'll do all the computations, right? We'll find the distance of rest of the data set from the cluster 1 and cluster 2 step by step, fine, until we get here, right? So let's start the computations. So this is our data, and first we have to calculate the distance from cluster 1 to itself. So the distance of 185.72 to itself will be the value of x will be 185 and the value of a will be again 185, because we are calculating the distance to itself, right? And again 72 minus 72, and after computation of this equation will get obviously 0, right? Now we have to do is to just calculate the distance from cluster 1 to cluster 2. So the data set of sample number 1 from distance from cluster 2 will be like this. So 170 minus 185 and 56 minus 72, 56 minus 72, right? So after computing this value, so after computing this 178 minus 185 and 56 minus 72, right? 56 minus 72, we will get 21.93, right? So now for cluster 2 we have to calculate the distance from cluster 1 and to itself. So for that here is the computation, right? Distance from cluster 1 for sample number 2, so it will be 185 minus 170, 185 minus 170 and 72 minus 56, 72 minus 56. So after computing we will get 21.93. Now from the distance from cluster 2 to itself will be again 0, 170 minus 170 plus 56 minus 56, and computing overall will get 0. So let's tabulate those all four results here. We can see here the distance from cluster K1 to itself, the axis cluster 1, so itself will be 0. The distance from cluster 1 to cluster 2 is 21.93. the distance from cluster 2 and cluster 1 is 21.93 again, and the distance from cluster 2 to itself is 0, fine. So these are two clusters, cluster 1 and cluster 2. So on the basis of these two data, right, like similar, we have to calculate rest of the data sample set to find the distance, right? And what will be the cluster for these rest of the data? We will assign 1 for cluster 1, we will assign cluster 2 we will assign value 2 for the cluster 2, right? So we will just find the situation of all this data set and define that whether the object is belonging to cluster 1 or cluster 2. So as per that situation we put the value of 1 and 2. So let's do the computation for next data. So we have done with cluster number 1 and cluster 2. So now move to cluster number 3. that is 168 to 60. So first we have to calculate the distance for sample number 3 to cluster number 1. So for that we have to do 168 minus 185. We have to put the values 168 minus 185 and 60 minus 72. So here is 60 minus 72. So again after computing this we will get 20.808. Now similarly we have to calculate the distance for sample number 3 to cluster number 2. So for that we have to put value 168 minus 170, 168 minus 170 and 60 minus 56. 60 minus 56. So computing the equations we will get 4.472. Now tabulate these results in one single table, right? So and do the tabulation. So in the table where is the result? Sorry, here this is the result, right? 20.808. the distance from this data to cluster 1 and the distance from this data to cluster 2 is 4.472. we have calculated here. So we have to find the minimum value from this. So let's compare it. So obviously the 4.472 is the minimum value as compared to this one, and the minimum value belongs from cluster 2. So the data will be the part of cluster 2. So we assign the value 2 for cluster 2, right? Now what happened here, that the data set 3 will be now become a part of cluster 2. So we have to update the centroid value, right? That is the means value. So we have to update the centroid value with the according to this. So the centroid value for cluster K1 will be remain 185 and 72, what is here, and for cluster 2 it will be get updated. So how will update? Because this two data set will get combined in cluster 2. So we have to add this two number, 168 plus 170 upon 2 is 169 and 60 plus 56 upon 2 is 58. So now 169 and 58 will be the updated cluster centroid value for cluster number 2. So now the further computation will be done just based on these 4 data, right? So remember this 4 data, right? So now we have to move on sample number 4. So for now for sample number 4 we have to calculate the distance of sample number 4 to cluster from cluster 1. So cluster distance from cluster 1 is here and distance from cluster 2 is here. So let's first calculate the distance from cluster 2, right? Cluster 2 for sample number 4 to 179 minus 170, but we will not take 170. We have to remember that because the updated cluster value, centroid value is 169. Okay, we have computed it here, right? We have to remember it, 169 and 58, right? So for 179 minus updated centroid value 169 and 68 minus updated centroid value 58, right? So after computing this equation we will get 14.14214. Now similarly we have to compute the distance from sample number 4, the distance of sample number 4 from cluster we have done with 2 from cluster 1. So here is distance from cluster 1. So 179 minus 185, 179 minus 185, right? And 68 minus 72, and we'll get 7.211103. Now tabulate these two results, right? So here is the result, and again compare these two data, and I think we can see here that 7.211103 is minimum value and this belongs to cluster 1. So the data sets 179 and 62 will be the part of cluster 1. So we assign the value, so therefore we assign the value 1 here, right? So the data set 4 and 1 will get combined in one group, that is cluster 1, and we have computed that 2 and 3 data set are in one group, that is cluster number 2. So as like we have update the centroid value of 2 3, similarly we have to update the value of also cluster number 1, that is sample 1 and for sample 4. So 179 plus 185, 179 plus 185 upon 2 is 182, and the 72 plus the 68, right? 72 plus 68 upon 2 is 70, right? And updated centroid value for cluster 2 is 169, 58. It will remain as it is. So now remember this 4 value, because the further computation will be based on these 4 updated centroid value as per the cluster number 1 and cluster number 2 respectively. Fine. So let's move on. Now we have to do the calculation for sample number 5. So let's calculate the distance of sample number 5 from cluster 1. So 182 minus 182, will not take 185, we will take 182, because we have just calculated 182 is the updated centroid value, 182 and 70. So just remember it, we have to take updated centroid value. So 182 minus 182 and 72 minus 70, right? So after computation we will get the 2 as a result. Now similarly we will calculate distance from cluster 2, right? So 182 minus not 170, we have to take updated cluster value, cluster centroid value, that is 169. I have to see, I'll just see here, 169 and 58, right? So 182 minus 169 plus 72 minus 58, 72, and updated centroid value 58. After computing this value we will get 19.10. So put this value in the form of table. So this is the tabulated form, and let's compare this 2 value. So 2 is the minimum value and it belongs to cluster 1, so this data will belong to cluster 1. So therefore I have to assign the value 1 here. 1 is for the cluster 1. So now 5 also get grouped together with sample number 4 and 1, which is named as cluster 1, right? So again as per the changes we have to again update the centroid value. So let's update. So 182 plus the previous updated centroid value 182 upon 2 is 182 again, and the 70, right, the previous updated centroid value, and 72 from here get add and divided by 2, we got 71, right? And the updated centroid value for cluster K2 will be remain same, that is 169 and 58. So now for the sample number 6, the computation will be done according to these 4 values, right? So let's move on. Now for sample number 6, the distance will be calculated first from cluster 1, right, from cluster 1. So 182 and 71 is the updated centroid value for cluster 1. So 188 minus 182 and 77 minus 71, 77 minus 71. So let's do this computation, that is the Euclidean distance formula, and after the computation we will get 8.4852. Now similarly calculate the distance from cluster 2, and the updated centroid value of cluster 2 is 169 and 58. So let's put the value 188 minus 169 here, right, and the 77 minus 58 here. So again we will get the value 26.87, right? So put these value in the tabulated form here, and just see what is the minimum distance. So 8.4852 is minimum as compared to this one, and this belongs to cluster 1. So the data set 188 and 77 will be the part of cluster 1. So I have assigned the value 1 here for cluster 1, right? And if there might be a continuous data set again for sample number 7 or 8, we just again have to update the centroid value, right? But this is okay, we have done with all these data set. So let's finalize the result in this form. So this is the sample data I have taken initially, and this is the final assignment. That we have 6 sample and their respective datas, and after applying all the methods, we have done with the clustering that sample number 2 and 3 belongs from cluster 2, and sample number 1, 4, 5, 6 belongs to cluster number 1. Fine, because the assignment 1, 1, 1, 1, 1 denotes clustering 1, and the assignment 2 and 2 denotes cluster number 2, right? So this is the accurate separation, and we can analyze it with the help of this diagram. Like we have 6 sample here in the form of mixture, and after applying k-means, what happened that after some iterations, the two data of similar kind get their space get together in cluster 2, and the 4 data of similar kind get place in cluster 1, right? So the mixture of this 6 sample gets separated, right? So now this kind of application is very much important in data separation in many areas, like in the data in business analytics, the data warehouse, and in data mining. So there are lots of applications of k-means clusterings which actually play a pivotal role in machine learning. So that's it for this video, and thank you.